In this video, we will look at UT setting. First, we will look at the general settings. Gain settings. First, set the gain value. It's the same button as in the top left corner of the topaz. You can either enter a value or use the plus minus signs to change the value by selected increment. The ref gain is to set a reference gain. When set, the reference gain takes the value of the current channel gain, and channel gain is set to 0 dB. Amplitude range allows you to find the amplitude range of your unit, which is the signal amplitude lower and upper limits considered by the system. It defines the maximum signal amplitude the Topaz 32 can read and store and can go up to 0 to 800%. The time-based settings. Set the start and range of the acquisition in the time base. Then set the time base type, true depth, half path, or distance. Next, we will look at pulsar and receiver. Voltage defines the amplitude of the voltage pulse that will be sent to the individual probe elements for the generation of the ultrasound beam. Your Topaz 32 unit offers different settings. The high is 75 V maximum pulse voltage, medium is 50, low is 35 minimum pulse voltage, or a custom value. You can select the current voltage value and manually enter a new one according to your unit specifications. The pulse width defines the width of the excitation pulse. You can choose either auto, which automatically selects the pulse width according to your probe nominal frequency, or custom value, which is the pulse width that can be set manually in order to optimize the configuration. For the rectification parameter, multiple types are available. The filter is a signal processing device that blocks a specific part of the received signal frequency spectrum in order to remove electronic and/or acoustic noise. The Topaz 32 allows you to use low-pass filters, which block signal frequencies higher than the selected filter value, high-pass filters, which block signal frequencies lower than the selected filter value, band-pass filters, which block signal frequencies outside of the selected filter value frequency, auto filter, which automatically selects the bandpass filter according to your probe nominal frequency. Bandpass selection filter is done by trying to keep the probe frequency in the middle of the bandpass filter range. None. No filtering is applied to the signal. The smoothing is a signal filtering process applied to a rectified signal to smooth the curve. Smoothing function creates an envelope on the rectified signal to eliminate the effects of the original RF signal. The blanking sets a lap between a recorded peak and the following peak. It can be considered a dead zone between two peaks. When a peak is detected and displayed, it will ignore new peaks coming for the defined time period in the A-scan recording. Next, we will take a look at digitizer. The acquisition rate defines the number of full set of acquisition that can be recorded per second. The recurrence is the furring recurrence frequency. The higher the acquisition rate, the faster you can scan. The higher the recurrence, the higher the acquisition rate, and the higher are your chances of getting ghost echoes. It's all about optimizing the parameters. The average parameter defines the number of A-scans acquired for each A-scan that is returned. An acquisition is obtained by calculating for each sample the average amplitude value over all the acquired A-scans. The possible values depending on your acquisition unit for the averaging are 2, 4, 8, and 16. Averaging reduces the effect of random noise. However, using a large number of acquisitions for the averaging decreases the maximum acquisition rate and therefore the scanning speed. Compression is used to set the digitizer compression ratio. The compression allows you to reduce the sample quantity along the ultrasound axis, and thus the final data file size, by keeping the position of the first sample and assigning it to maximum amplitude of the considered group of samples. In this figure, you see an example of compression by 4. Compression reduces your ultrasound axis resolution and has the same effect on signal as defining a maximum number of points for your A-scan on other portable PA systems. The record condition is useful if you don't need all the data for the acquisition. Different conditions can be set, either C-scan only or gate conditions. In the case of a gate condition, the A-scan will only be recorded when signal is crossing the gate. The log gate condition will record only the beam where the signal crosses the gate. The channel gate condition will record the whole channel every time the signal crosses the gate somewhere. The digitizing frequency gives you the information about how the signal is converted from analog to digital signal. Let's first consider an unrectified signal. An analog/digital converter will basically lay a vertical grid equally spaced and record for each intersection on the amplitude of the signal. The distance between those vertical grid lines depends on the digitizing frequency. For each intersection between the grid and the signal, a table is built with time and amplitude. This is the raw data that is stored in your data file with position information. When you perform a digitization, there will be a discrepancy when it comes to signal amplitude. The worst case is the case shown here, where the tip is in the middle of the two samples, so you miss the maximum peak of your signal. In this example, there's a digitizing frequency for a 5 probe. In the case of the Topaz, the digitizing frequency is locked to 100. Digitization with the ultrasonics is somehow similar to the number of pixels you have on your digital camera. The more pixels you have, the better quality the picture. Now your system allows you to either digitize it in 8-bit or 16-bit. For example, the two pictures we have here look pretty much identical, but one of them was taken with a higher resolution. For the sake of this demonstration, let's just say that one is 8-bit and the other is 16-bit. Just like the pictures, the more resolution you ask for, the bigger the file size. Next, we will take a look at gates. In the UT settings, gates menu, a synchronization gate and multiple detection gates can be set up. The synchronization gate is useful in multiple cases. A good example would be an immersion probe over a changing surface, because in a case like that, the interface echo moves in the U-sound axes and may not always be at the same depth. Using a synchro gate on the interface echo and setting it to sync on echo will put the position of the echo at the 0 position of the ultrasound axis ruler, no matter where it actually is in the immersion tank. Detection gates can also be set up. To do so, first select a gate to be activated, then change its state from off to on. Once the gate is activated, it can be seen both on the sectorial view and the A-scan. Each gate has a different color. To use the gate, set its start and range to the area of detection. Multiple trigger options are available. Crossing will detect the position where the signal crosses the gate at the given threshold. Maximum will detect the position of the signal with the highest amplitude. Crossing will detect the position where the signal crosses the gate at 50% of the amplitude of the maximum peak. The gate can be used afterward to create a position or amplitude C-scan. Gate parameters are also available offline, and a software gate can be created at any moment, and the associated C-scan will be updated accordingly. If you did a TCG calibration previously, you can come to the TCG menu and transform your TCG. The TCG menu can be used to activate a curve. Select the appropriate mode and then create each points manually. Lastly, we will look at alarms. The alarms are set using gate conditions. Up to 4 alarms plus a synchronization alarm can be set. To set up an alarm, you first need to have at least one gate activated, and then you can set up the alarm conditions. Consecutive hit is how many times the condition must be met to turn on the alarm. The alarm condition is set using the fields condition 1, condition 2, and condition 3. To have multiple conditions, you must have multiple gates activated. An example of condition could be signal crosses gate 1 or signal do not cross gate 1. Another could be signal crosses gate 1 and gate 2 at the same time, or signal crosses gate 1 but does not cross gate 2. You can also set up the duration of the alarm once it is triggered and reverse the logic. An example of reverse logic could be the initial condition is that if signal crosses gate 1, the alarm is triggered. The reverse logic of that would be that if the signal does not cross gate 1, the alarm is triggered. Thank you for watching. If you have any questions, please contact us at support-utproducts@ztech.com.